Hello, my name is Rocky Neese,
And I'm Robert Romansky.
and we'll be talking about side channel attacks, specifically those pertaining to attacks using the electromagnetic spectrum. So in order to help visualize this problem, I want you to imagine a snake hunting a mouse. When a snake hunts a mouse, it not only does rely on its eyesight, it uses some other sort of seemingly innocuous data to sort of to create a picture of the mouse. And that is including its smell, including its heat signature, both of which you can detect in great detail and sort of help develop not only like where prey is, but the size of the prey, the health of the prey, etc. Really complex data pulled from things that seem sort of relatively innocuous. Taking this metaphor sort of, in a larger picture, in 2018, the fitness app Strava, they released a heat map, which was a visual representation of all the run routes, exercise routes used by its users, depicted by a map of heat or where brightness was in relation to the frequency of an exercise route used, juxtaposed against satellite imagery. Now, the seemingly innocuous data, this app was being used by some members of the U.S. military who were cataloging their run routes. And this data was then sort of released and showed military bases, not only their locations, but from looking at this image, you can determine the layout of a military base. If you look at the different times and run routes being used, you can determine the patterns of life on the military base. You can also determine the readiness posture of the military base and other sort of operations going on. So very seemingly innocuous data, an app used by few people on the base that's completely unrelated to the military was providing a very critical information to potential adversaries to be able to plan and exploit and conduct attacks. In a similar fashion, our computers release information in environments that are seemingly innocuous. These bits of information being the patterns of power consumption when different circuits burn through power as they're doing the computation, the communication between the touchscreen and the display, as well as the time in which different computations take. All of this sort of seemingly innocuous information sort of released into the environment, imperceivable to human beings, but all of which can be used to sort of exploit more critical data in a side channel attack. Now, divining very critical piece of information like keys, passwords, etc., from this sort of amorphous, intelligible pool of electromagnetic radiation and heat and random timings seems to be a very sophisticated process, and only seems possible at first glance by at least requires the sort of material and technological sophistication of a nation state. But it turns out that is not the case. In the 1980s, Wim van Eck, a researcher at Twente University, was able to eavesdrop on a system from a few hundred meters away with only $15 worth of equipment and a television set. Really indicative of the fact that this data information can be exploited by an attacker with very low means and very low technological requirements. Additionally, the sort of motivation to learn more about these problems and mitigate them is that they are non-intrusive, meaning that it's difficult to tell when someone is in fact collecting this data on your system, as well as they're very difficult to detect, and they're employable with other methods of attack. They have a low opportunity cost, and that Van Eck freaking, which is the process of collecting this electromagnetic radiation that Wim Van Eck created in this time, doesn't interfere with any other methods of cyber attack that an adversary would like to employ. And it definitely doesn't interfere with other methods of side channel attacks. I think you muted yourself, Robert.
Oh, thank you. We're going to be taking a look at electromagnetic radiation attacks. And again, from top to bottom there, we're going to be looking at the electricity consumption, looking at the electromagnetic emission from the screen of a device and see what that looks like. We're also going to see what observing and injecting light into a transistor will do for side channeling attacks. Again, on the right-hand side there, you see a picture of a transistor, and then how can we inject or read things from that transistor to facilitate an attack. On the bottom left-hand corner, you see a thermal profile over time of what it looks like on a certain chipset when a certain password was entered. So that's more of an example of a thermal attack, and we can see how a signature, a thermal signature based on activity. And for example, we can know when a certain user logs in based on this thermal activity, and then know that it's the time to initiate a side channel attack. And again, all of these attacks are assuming that the attacker has physical access to the device. So that's something good to think about when we're thinking about preventing side channeling attacks. Slide, please. Again, simple power analysis, we're looking at the change in power over time. If a certain function or if a certain function is successful, like a password has been authenticated, then the power analysis or the power curve may be different. And so if we can get a footprint of that, we'll know when a certain action has succeeded or not succeeded and know what to do next in our side channel attack. Next slide, please. Then with screen gleaning, again, using an electromagnetic probe to read the emissions coming from, in this case, an LCD screen. Like Peter mentioned earlier, they would be reading it from a cathode ray tube in the 80s. Now we'll be using an LCD here from the 2000s on. Weaker signal, but with a probe we can do that. And then with these emissions on a trained neural network, we can see what these emissions probably are with a good probability. And so again, just with that data from that probe, we can read what's on the screen, even if something is in front of it. And so what else do we need to know about that? That's really about it. And then again, if the signal isn't strong enough, one can make it more sensitive or amplify it. But that's pretty much it. Next slide, please. And then with photon attacks, again, that's where we can read optically what's happening on a semiconductor. Semiconductors, they're using electricity, and that electricity emits some light, and so we can observe the light being emitted from all those semiconductors. And if a certain function happens, we know what that profile, what that footprint looks like, and can start our attack. And if we want to attack something using photons, or in this case, a laser, for example, we can shine a laser on a transistor, and it's going to suppress or deny that function from happening successfully. And if that, let's say that function is a security critical function, we can stop that from happening with this photon attack. Next slide, please.
So when we think about defending against these various forms of side channel attack, I want you to, I'm going to sort of borrow a metaphor from the military. And at the military, you want to hide your radio communications, your light, all these other indicators of your location, your plans, and your disposition from the enemy. And there are sort of two schools of thought to this. There is blinding with darkness or blinding with light. So in blinding with darkness, you do everything to sort of hide as you can, minimize how often you're communicating, harden up your positions, all these various things. The other theory is blinding with light, and that is where you blast as much signal and light out into the environment, and you also set up other sort of fake locations that are blasting this radio traffic and light into the environment, such that you sort of blind the enemy with this very large amorphous picture of various different locations, all giving out so much data that they cannot really comprehend it to form a cohesive picture, because you supplement it not only with you being as loud and bright as you can, but also having a bunch of fake positions that are also loud and bright as possible. So when we think about the defense, it's sort of the two ways to frame it. So in the example of blinding with light, between the touch screen and the display, you can have your system provide random keystrokes that are sent to the kernel that are eventually filtered out by the operating system. But as the attacker is using that cathode ray tube to pick up the signal, they're getting those random keystrokes, therefore rendering their data useless because it's unable to determine what is an actual keystroke and what is a fake one. You can do the same thing with power consumption in circuits. You can have it programmed that different circuits, though they're not doing an actual computation, will be consuming power for some reason, or you can have artificial sort of breaks in the computation and the array. So that way there's a sort of false signatures being given off that are then interpreted by the attacker as actual data, when in fact it is sort of a false positive. You can do the same with adding time variance to CPU functions. So as different functions CPU sort of run their calculations, you can have it built into the program for them to sort of pause, stall, or sort of do various other things to make it seem like they're running or running longer than they should be, thus also rendering that data useless. Now, on the other side of blinding with darkness, one of the ways you can prevent is to think about it for devices is you can prevent them from emitting as much light as possible. So you do this by hardening the circuits. So that way, not only is most of the photons not sort of emanating from the device, but also you can't conduct a photon attack of using a laser to sort of trigger different circuits because it will sort of be shielded from that action. Additionally, you can sort of obfuscate the reverse entering the firmware. So one of the ways they sort of can get data is they can take a firmware image and then take that image, run it through code in order to get information about the software. If you can expect this of the attacker, you can array your firmware image in such a manner that when run through code, it will be utter nonsense and gibberish. So all these are different methods to sort of prevent against side channel attacks. And the way to sort of group them mentally is either blinding with darkness or hiding and hardening, or blinding with light, which is sort of giving random incorrect data. So in conclusion, there's sort of the two main takeaways from this, is that side channel attacks have a very low opportunity cost with a very high ceiling for attackers. Wim Van Eck was able to prove that you can conduct a side channel attack with very low equipment without much technological capability. They're not very intrusive, which means it's difficult to detect when they're occurring, and they can be used in coordination with each other, and in fact are much better in being used in coordination with each other. The example with the mouse shows that it is the combination of both smell, sight, and the thermal image that a serpent is able to sort of develop a useful image of the mouse. In the same way, different side channel attacks provide different aspects of data to sort of allow to make it much easier to exploit the system. And then when it comes to defense, there are sort of two prime ways. That is blinding with light, blinding with darkness. You either over communicate with false information by having the CPU's power consumption, the communication from the touch screen to the display kernel to provide false information. So that way you're over communicating, you're sort of blinding the attacker with all of this data, most of which is useless. Or you can blind with darkness, where you sort of harden and hide your circuits as much as you can to prevent them from emanating or giving off this electromagnetic radiation, as well as preventing them outside environment from being able to interfere with it. The issue, of course, being that with both of these, that they both require more time and they require sort of more money investment involved. And brief.